For this video, I won't be using ask because I need to draw pictures. What I have here is a picture of something called a state machine, or to be more exact, a finite state automaton. This is a very simple model of computation. Each of these nodes is called a state, and when the machine computes, it transitions between states by following the arrows. The input to this machine is a string of characters from an alphabet. So in this case, I'm going to say that my alphabet consists of 3 letters A, B, and C. So let's run the machine on an input to see what happens. So let's say our input string is the string A, B, C, A, B, C, A. So to start out with, we are in the initial state, and the initial state is the one which is marked with a arrow. The arrow which is coming from nowhere coming in is marking what's the initial state of the machine. So we're in the initial state and we read the first letter of this string, which is the letter A. So what we do is we find the arrow going out of the initial state, which is labeled by A, namely this one. And we follow that arrow to go to a new state. So after reading the letter A, we go into this state. And then we repeat. So the second letter is B. So we find the arrow out of the state that we're in, labeled by B, namely this one. And so we go to this state. Then we see the letter C. So we find the arrow out of that state labeled by C, namely this one, and we go back to this state. By the way, the arrows which are labeled with B, comma C are really a shorthand for 2 different arrows, one labeled by B and one labeled by C. So now at this point in our string, we've read A, B, C, and then we read the letter A. So we go to here, and then we read the letter B, so we go to here, and then we read the letter C, so we go to here, and then finally we read the letter A, and then we go to here. So at this point, we have read all of the letters of the string and we've arrived at the end. So what do we do now? Well, notice that the state that we're now in is drawn a little bit differently. It has an extra circle around it. This means that it's something called an accepting state. So the output of this machine is going to be a Boolean, either true or false. And the terminology that we normally use for state machines is when the output is true, we say that the machine accepts the string. And when the output is false, we say that the machine rejects the string. So the states which have an extra circle around them are the accepting states. So when we get to the end of the string, we look to see whether the state we're in is an accepting state. And if it is, then we output true or accept. And if it's not, then we output false or reject. So in this case, for this example, we've ended in an accepting state. So this machine accepts the string ABC, ABC, A. Okay, let's do another example. Let's say our input is the empty string. So again, we start in the initial state, which is the one labeled by this arrow. So we are here. And if our input is the empty string, then we've already reached the end of the string. So what we do is we check to see whether the state we're in is an accepting state or not, and it's not. The initial state of this machine is not accepting because it doesn't have a circle around it. So we say this machine rejects the empty string. Okay, whoops. Okay, now I'm going to tell you a description in English of what this machine does, and then you'll know all of the strings that it accepts and rejects. So this machine accepts all of those strings that contain the letter A an odd number of times and contain the letters B and C an even number of times in total. Okay, so that seems that it came absolutely out of nowhere. So how could you see this? Well, this machine secretly has 2 bits of memory. The first bit is whether you're in the left half or the right half, So we have, this is 0, 1 for the first bit. And the second bit is whether you're in the top half or the bottom half. So this is 0 or 1 for the second bit. And what these two bits are doing, and notice we have 4 states, and 4 states is the number of configurations the 2 bits can be in. So we have 0, 0, 0, 1, 1, 0, and 1, 1. Okay, so what these 2 bits of memory are doing in this example is that they are keeping track of the first bit is keeping track of whether we've seen an even number or an odd number of the letter A so far. And the second bit is keeping track of whether we've seen an even number or an odd number of the letters B and C in total so far. So what happens is each time we read a letter, if we see the letter A, we flip the first bit, keep the second bit the same. And if we see a B or a C, we flip the second bit and keep the first bit the same. So, and then the initial state is 0, 0. This says that when we start, we've seen an even number of both, namely 0. And then we accept if we're in the state, if our bits read 1, 0, which is we've seen an odd number of A's so far and an even number of B's and C's so far by the time we hit the end. Okay, so this is really illustrating finite state automata just by an example. So for this video, it was quite good to be able to come out of Ask and draw pictures, but in the next video, we're going to go back into Ask and we're going to implement these things in Ask.